Okay, welcome Roxy and Denise and Sophia and Luz and Nate and Maddie and Jack and Marquette, Marina, Jose, Jacqueline, and welcome Braulio also. So let's share my desktop and take a look at the quiz. Okay, so here's the quiz. And it says data was collected on 259 surgery patients at a hospital about the type of anesthesia they had while there and whether they came through ER or if they had an appointment. The results of the study are shown in the table below. So here we got general, local, and regional anesthesia versus ER versus appointment. So we have what's called a contingency table. And then there's a whole bunch of questions. So one thing you might want to do right away is come up with the totals. So let's do that. And I think I put it down here. So let's come up with the totals. Here we are. So I think pop it in here. There we go. I'll call it T for total. And the total in ER was 32 plus 18 is 50 plus 25 is 75. The total for the appointments is 47 plus 78. And that is, let's see, 125 plus 59, which is 184. And now let's come up with the totals for the other categories. So for the general, let's try T again for totals. For the general, we have 32 plus 47 is 79. We have 18 plus 78 is 96. We have 25 and 59 is 84. And now let's add these up. So 184 plus 75 is 259. And then let me double check. 79 plus 96 is 175 plus 84 is 259. Good, it worked. I always like to double check, especially when I do it in my head. You don't have to do it in your head though. So those are the totals, and that's going to help us out a lot. So now that we have the totals, we can answer some questions. So if a randomly selected surgery patient is observed, what's the probability that patient made an appointment for a surgery with local anesthesia? Okay, so that's a probability. It's always good to write it in symbols of what? So it's P of what?
Probability of appointment and local.
Okay, well, yeah, so it's a probability. So let's look at it. If a randomly selected surgeon is there, what's probably the patient made an appointment for a surgery with local. So there's appointment and local. I can call that A and L. Okay, so now what we do is we just look, and what's the numerator?
78.
Yep, 78. And what's the denominator?
259.
And that's all there is to it. Any questions on part A?
Is it okay if we answered in a decimal?
Yeah, that's fine. I think it's easier to answer in fractions. And it also tells a story better, you know, if you're kind of showing that you understand what's going on. The problem with the decimal is if you make a little mistake, like, I don't know, you switch the numbers or something, I won't know, and I'll just give you a 0 because it's just not the right decimal. Does that make sense? But if you write a fraction, and let's suppose that you had the 259 right, but you had the 78 wrong, then I can give you partial credit for at least having the denominator right. Whereas a decimal, if it's just the wrong decimal, I can't give partial credit. Does that make sense? So for the exam, for example, I strongly recommend leaving as a fraction for these kind of questions so that you can get points if you make a little mistake. Now, if you get, if you have no idea what to do and just make up a fraction, you probably won't get points, but you'll probably know how to do something. Okay, B is what's the probability that a patient that came into the ER had regional anesthesia? So in symbols, what's that the probability of?
Regional given ER.
Yeah, that's going to be regional given ER. Any questions on how we came up with R given ER, regional given ER? Okay, well, once we know that, it's actually quite easy. So now let's go to the table. So probability of regional given ER, what's the numerator? What's the numerator?
25.
Yeah, 25. And what's the denominator?
75.
Yep, 75, because we're given ER, which means we only look at the ER's row. So it's 25 over 75. Okay, so once you have the totals written in, all of this is really quick, as long as you understand how these work. Okay, are making an appointment and having general anesthesia mutually exclusive? Explain numerically. So what probability do I need to check on to find out if they're mutually exclusive?
Appointment and general.
Yep, so A and G, I'll call it. And let's calculate probability of A and G. What's the numerator?
Janine! What is that?
So what's the numerator for appointment and general?
47.
47, and the denominator is?
259.
Yeah, 259. So it's 47 over 259. What's the important thing about that fraction?
It's not 0.
It's not 0. So what can we conclude?
It is not mutually exclusive.
Yeah, they are not mutually exclusive. I'll write ME, less typing. Any questions on part C? Okay, next are making an appointment and having a local anesthesia independent. Explain numerically. So now I need some probabilities, and we can choose which one you want to do. I like to do the given because it's less work. So the probability of, it doesn't matter which way you go, appointment given anesthesia. So what's the probability of appointment given they had local anesthesia? So what's the numerator? For appointment given local?
78.
Yep, 78. In the denominator?
96.
96. So that's 78 over 96. This is the one time where you actually do want to get in a calculator, 78 over 96. And I get 8125, 0.8125. And then we also need to find out the probability of an appointment. So let's take a look. So what's the numerator for probability of an appointment?
$184.
What's the denominator?
$259.
Yeah, so 184 over 259. And that we probably want to pop in a calculator because we need to see if those fractions are the same. The easiest way of doing that is to turn those have to be turned into decimals. And that's 0.7104. Okay, and What was the point of all this? What can we say?
They're dependent because they're not equal.
Yeah. So since they are not equal, they are dependent, not independent. Okay, and finally, if a randomly selected surgery patient is observed, what's the probability that the patient came into the ER or had general anesthesia? That's the probability of ER or general. Now we had a little formula, and hopefully you remember that was the probability of ER plus the probability of general, and then minus, how did it go? Probability of general, not plus, but and. So ER and general. Yeah, probably a both. I see. That's what you're writing. Okay, and notice there's no givens here. They all have the same denominator, so we can just add up the numerators. So ER, start there. And there were 75 ERs. And then the Gs, generals, there were 79 generals. And then minus ER and general. Then that's 32. Over the same denominator that we've had all along, which is 259. And if you want to simplify it a little bit, you can. You don't have to. But let's see, 79 minus 32 is 47. 47 and 75 is 122 over 259. Any questions? Any questions at all on this quiz? Any questions? Easy to watch, isn't it? I'm not sure about doing it, but you know, you just kind of follow along. So the most important thing is if you don't do well on these quizzes, what should you do?
Review them.
Yeah, review, practice, also get help. So I have office hours, Braulio has many hours, and you know, we're here for you. But again, if you don't go look for help, it won't go well for you. So make sure that if you're not getting things right, don't just say, oh, it'll just go away, because it won't go away. That's when you need to go out and, you know, go to Braulio's office hours, you know, or any of the stats tutors hours, and get help, come to my office hour, but make sure you can get this stuff down, or because you're gonna have to do things like this possibly on the exam. It won't be this problem, but that's just really important to note, is that don't just say, oh, the quiz is over, I'm not even going to think about it for, you know, a while. Yeah, if you did do well, then you say the quiz is over, I did great, time to party. If you didn't, then the quiz is over, I didn't do well, so I'm going to spend all day tomorrow working on this stuff so that you can make it. So that's the most important thing. Any questions at all on any of the A through E on this quiz?
I actually do have a question on the independent and dependent. When you're proving that they're like not dependent, could you have also done, or that they're dependent? Could you have also done the probability of that, like both of them?
You mean with an and?
Yeah, with an and then compared that to.
Okay, so you can do that, but let me tell you why I didn't. Okay, it wouldn't be wrong to do that. So you can compare the probability of making an appointment and having anesthesia with the probability of making an appointment times the probability of having anesthesia. Does that make sense?
Yeah.
Okay, but here's the reason why I like my way better because how many probabilities did I have to calculate?
Two.
2.
Yeah, and you have to
Okay.
calculate 3 and the other one.
Yeah. So the other way you have to calculate 3.
Yeah.
And I don't know if you want to do 50% more work, you can. It's not
Oh.
wrong.
For some reason, I thought we had to prove like we had to do it both ways.
No. There's a theorem which I didn't prove, but I did state last week is that if one of them is true, they're all true. If one is false, they're all false.
Okay, that's good.
Yeah, so you only have to show one of the 3, whichever seems easier. And if you don't have any information, but you have a table, then the and one is always the hardest.
Okay.
Okay, it doesn't mean you can't do it. I wouldn't take off points if you did the and one right and said they were dependent, but you might run out of time.
Yeah, I did run out of time and I didn't even have time to explain it.
Yeah, and that sometimes can be a problem if you run out of time. Sometimes that's because you didn't do it in the efficient way.
Yeah.
And again, if you're running out of time, then practice is important so you can get faster.
Okay.
Okay, other questions? Good question though. Okay, are there questions about the project or about anything else? And again, I noted the project because that's the big thing coming. So are there questions about anything? It doesn't have to be the project, it could be other questions, but I wanted to focus there. Are there any questions?
I do have a question about the project.
Sure.
For the Z-score,
Mhm.
I know what it says, explain how you'd use it in your study. I'm kind of confused because I thought it was used to usually compare values from different data sets.
Okay, so there's a lot of uses of Z-score. One is what you just said.
Mhm.
That's not going to be very important in your project because you only have one data set.
Yeah.
So let me tell you some other reasons why you care about the Z-score. If you want to see if there's outliers. So you can find the Z-score for the maximum value and see if that's an outlier. You can find a Z-score for the minimum and see if that's an outlier. And let's say the minimum was an outlier, then you might want to check the second lowest and see if that's also an outlier. Does that make sense so far?
Yeah.
The other reason why you care about Z-scores, and the other use that might work on your project, depending on your project, is that if there is a natural value of X, so for example, if your survey was, how many hours of sleep did you get last night? Then you might want to look at the Z-score for 8. And if the Z-score for 8 was say, was say 1.9, then you would say, look at that. It's way above the mean and people aren't getting enough sleep. Does that make sense?
Yeah, that does make sense.
So the 2 main reasons for the project, one everyone will do, and that is checking for outliers. And that can be done for every project. And the other is if you happen to have a number that is just kind of everyone knows that number, it's the big number, then check the Z-score on that number. Okay, and your idea is great for other kind of projects, but not this project, where
Yeah.
you're looking at 2 different data sets. Because
Oh, sorry.
Hmm?
I was gonna ask if we have like a value that not exactly natural, but that our client would want. Could
that's
we?
natural. That's natural.
Oh, okay.
It's natural to your client. Again, when I say natural, I mean natural to whatever situation your project is about. Do you
Okay.
see?
Yeah. So then how would we use the Z-score for that exactly?
Okay, so the Z-score tells you how unusual that value is. So if the client wants it to be unusual,
We look at
a Z-score of 0.1, you say, oh, the client's not very happy because it's not unusual at all. Does that make sense?
Yeah, okay. I get what you're saying.
Yeah, if the client doesn't want it to be unusual and you get a high Z-score, you say, oh boy, it's unusual and that's, bad for the client. Does that make sense?
Yes.
Yeah. Okay, other questions? Good question, really good question, because this isn't just for you, but everyone needs to be including the Z-score And it's one of the hardest parts for the project. And my definition of hard is students either ignore it or don't interpret it right. And I've been teaching this with these projects for a long time. So I see what goes on, and that's one of the biggies. Okay, other questions? Okay, if there's no questions, then I have a question for you. And let's see if you can remember. Again, it's been 2 weeks already. Do you remember the difference between a discrete and a continuous variable? See if anyone can shout it out, chat box, or talk. So what's the difference between a discrete variable and a continuous variable?
In a discrete variable, one that's where you count like the numbers, like 1, 2, 3, like, and then continuous is like where you measure them.
Okay, so counting 1, 2, 3, 4, 5 is definitely an example of a discrete variable.
Mhm.
Okay, where if the answers are 1, 2, 3, 4, 5, those aren't the only possibilities though.
Mhm.
But that's definitely, you know, one of the biggies. But you're kind of, the idea is that you can be, not counted is probably not quite the right word, but listed. Is that you can list all of the possible values. Sometimes you need dot, dot, dot. Sometimes you don't. More often you don't. So that might be something like, you know, how many times have you been to Europe? Well, you could list all the possible answers, right? You can't have been to Europe 3.145 times. Okay, but you could have been to Europe 8 times, or 2 times, or 0 times, like me. Does that make sense? You could even have like fractions, but not all fractions, it turns out. So that would be things like how many siblings are in your family, and you could have half siblings. So that, do you remember that happened a couple weeks ago? I promise you it did. So let me remind you of the big definition. So a discrete variable, let's make it red, is a quantitative variable. So do you guys remember what quantitative means? Very important word.
Numerical.
Yeah, it means the answer to the survey question, okay, or the data that you're going to put on the paper will be numbers. So it's a quantitative variable whose set of outcomes can be displayed as a list. Okay, quantitative variables that are not discrete are called continuous. I will let you know that if you truly understand what continuous means, that means you're a math major. So just trust me, it's actually very deep. So we're not going to get into the true definition. It's way too hard. But I want you to get the idea, like be able to identify, hey, this one's discrete, because I could list them all. Okay, so that's just a little heads up, a little disclaimer, is that this is only kind of works. Okay, for a discrete variable, a probability distribution table can be created. Okay, so that's the important thing, is that you can put it in a table. Sometimes you have to use kind of dot, dot, dot notation on the table. That won't happen in our class. In our class, we'll stop. It'll always be a nice finite number that you can pop into a table. So any questions at all about the definition before we look at an example? Okay, if there's no questions, then let's get into the example. So here's the example. A car salesperson gives out a $10 gift to every customer who test drives a car. Okay, I don't know if you've heard of that before, but sometimes you come into the dealership and they give you some kind of, some kind of prize, gift certificate, or present, if you test drive the car. Okay, just to get you in. Okay, common business. 12% of all customers who test drive a car purchase the base model of the car, resulting in a $200 commission for the salesperson. 8% of all customers who test drive a car purchase the deluxe model of the car, resulting in a $300 commission for the salesperson. Okay, do you understand what this is saying in terms of how the salesperson is making money? Any questions on it? Give you a second. Any questions? All right. So first thing, is this discrete or is this continuous? If we're talking about the profit as our variable.
Continuous.
Okay, so if it's continuous, all right, that means you could list an infinite number of things that could happen. Could you list even 100 things that could happen for this one person who comes in to test drive a car?
No.
Yeah, so I like what's in the chat box, discrete. This is discrete. How many different things can happen?
Yeah.
Read it carefully. We don't take the majority, by the way, because 2 is not the right answer, even though we got, most people said 2. Yeah, 3 things can happen. Okay, so let's take a look at the 3 things that can happen. So what I need to do is, the question is, let's write down a probability distribution table for this particular example. So there are 3 things that could happen. So I'm going to insert a table. And there's 3 things that happen. I'm going to put labels. So I'm going to make it a 4x2. So I'm going to let X be the letter for the variable. That's standard. And then down here, I'm going to write P of X, because this is a probability distribution table. So X are the things that could happen, right? The values that could happen. And P of X are the probabilities of each of those things happening. Yeah, exactly. The 3 things that can happen are, I'm going to do it in the order it's written, by standard, by deluxe, or by nothing. Okay. So what is the profit if a customer comes in and ends up buying a standard model? What is the profit?
$200.
What is it?
200.
Okay, so we got to remember, yeah, I like what's in the chat box. The definition of profit that you learn, that you might have seen before, is the revenue minus the cost. Does that sound familiar? So the amount that you make minus the amount that you have to spend is your profit. So it says that you're going to make $200, but you got to give that gift certificate out. Okay, they buy the car, you still got to give the gift certificate. So if you take 200 and you subtract 10, then you get 190. Any questions? Any questions on getting that first value of X? Okay, what about the next value of X? So what about the deluxe? The person who comes and buys a deluxe model. And what's the profit? Yeah, exactly. So you're going to take the 300, because that's your revenue, and you're going to subtract the $10 gift, that's your expense. The revenue minus the cost is going to be 300 minus 10, which is 290. Any questions on that? Okay, what is a profit if the customer comes in and buys nothing?
-10.
Yeah, it's -10, because your revenue now is 0 and your cost is still 10. So 0 minus 10 is -10. So any questions at all about finding the values of X for this probability distribution table? Any questions? Okay, so now we need to find P of X. Okay, we've written all the values that could happen, now the probabilities of those values happening. So what is the probability of ending up with a profit of $190? The answer is it's not very hard. So what's the probability of profiting $190? It's basically written in the problem.
12 over 100.
What is it?
12 over 100.
12 over 100. I like to write as decimals, which is 0.12. And the reason I like decimals is that's how we're going to write it in the calculator. So it's better not to write as a fraction if you don't have to for these probabilities. Okay. Now we want the probability of profiting $290. What's that going to be?
0.08.
Yeah, 0.08. Because 8% is 0.08. Then we need to find out what is the probability of profiting negative $10. That one you have to do a little work on. A little harder, but not that bad.
0.80.
Yeah, let me go through the details of that. Okay, and that is, we can use the rule of complements. So notice what we can do is we can take 1 minus the sum of 0.12 plus 0.08. Okay, that's called the rule of complements. We know by the fact that we have a probability that the sum of all the probabilities has to equal to 1. So if you know all but one of them, then the one you don't know, you can just do 1 minus the rest. And 0.12 plus 0.08, 12 and 8 is 20, or 0.2. 1 minus 0.2 is 0.8. Any questions? I mean, by 80, just so you don't get it confused with the 0.08. Any questions on this probability distribution table? Any questions? So I do want to give you the warning. It's a lot easier to watch me do it. You're probably used to that now in this class, right? So you definitely are going to have to, practice your own.
I'm just saying, like, hearing you say over and over how difficult things are is not exactly encouraging or helpful.
Well, no, I didn't say it's impossible. I'd say you need to practice. That's all.
Not very helpful.
You just need to practice. So I'm not saying you can't do it, but I'm saying you might need 3 or 4 examples of working out by yourself, and then you'll get good at it. That's all. Okay, I don't mean you can't get good at it. That's for sure. Okay, a lot of students actually get really good at this and get 100% on this kind of problem. That is common for a lot. But those who don't do any practice, it doesn't go well. That's all I'm saying, is that you want to practice. I'm not saying you can't do it. Okay, and in fact, the good news, unlike chapter 3, I didn't give you the warning that I gave you in chapter 3. Chapter 3, I gave you the warning that was a really tough chapter. This one, what I found is the hard workers almost always get the problems right on the exam when I put these on the exam. So if you want the good news, that's the good news. And those who don't do any work, they don't get anything right anyway, because if you don't do any work, good luck. But the hard workers do just fine on this. So this one should go well. Okay, but don't just assume that you don't have to do anything. Make sure you practice, is all I'm saying. Hopefully that makes sense. Okay, so now what we want to do, one of the things you might want to say is, let's suppose that you're looking at the prospect. Do you think there's a job you might want to take? Does it look like a good job financially?
No,
It doesn't? How come?
because you have an 80% chance of losing money.
Right, you have an 80% chance of losing money, but if you do make money, you make a lot of money. Does that make sense?
Yeah.
So the answer is more complicated than just saying 80% chance of losing money. Let's forget that. Okay. The answer is we need to actually see what this looks like. So again, one person said no, 80% chance of losing money. Forget that. Then we got one absolutely looks good. So again, we got to look at this and what we want to do to see if it's a good job. Okay. In terms of financially, again, if you hate selling cars, then it would be a bad job even if you made a lot of money. I'd hate this job. But if you're looking for money and that's your purpose, then we have more work to do. We want to say, well, that's, for one person, we can look at these probabilities. We're just not going to just have one person. We're going to have a lot of people come in. Okay. We're going to make that assumption, make the assumption that you're going to be able to work all day and not sit at a desk all day without having people come in. Okay. You're actually going to have people coming into your sales shop and be able to show them cars all day long. And the question is it profitable in the long run? Does that make sense as the question? Okay, so if you do this and have many customers, what do you think your average amount of money you're going to make per customer is going to be? Any questions on the question? Okay, so because of that, we're going to have a big definition. And this is called the expected value. It's probably the biggest of the chapter. And it's the following. So if many trials are done, like I said, if you have many customers come into your auto sales shop, okay, then it is very likely that the average of the trials will be very close to the expected value. Okay, so that's the definition. That's what it means to be an expected value. So I want to mention, and hopefully you can see, that there are words highlighted in red. Do you all see them? What words you see highlighted in red? Not a trick question. Yeah, we got close to, we got average. Okay, we got a couple more. What else do you see in red? Many, and what's the other one? And likely. Okay, so here's something I'm going to let you know. On exam 1, there will be an expected value question on the exam. Okay, that's guaranteed. And you're going to have to interpret the expected value. Do you know what's going to happen if you don't have many, likely, average, and close to written in your interpretation? Do you know what will happen on the exam? Any guess?
You will get it wrong.
You get it wrong. You'll lose points. Let's put it that way. Because it's not wrong or right. It might be 15 points, and then you'll lose a few points. Maybe a point for each of the words that you miss. So I'm guaranteeing you, this is something that you know. So come into the exam, and it's better than that. Not only will you lose points if you don't put these words in, but if you do put the words in, you get points, even if everything else is nonsense. Hey, if you got these words in, I'll give you some points just for having the words. Okay, so promise me that you'll actually, put these words in. And remember, you get a note card, so you can put them on a note card if you want to remind yourself to put them in, because I'm guaranteeing it's going to be on the exam. Okay, so just a note that, that's going to be there. Any questions on the idea of this expected value, which is, again, probably the most important of all topics for this chapter. Any questions on what this expected value means? Okay, so just a note, I'll do an easy expected value, which I'm guessing you can all do in your head. Let's say I flipped a coin, heads or tails. You get $1 if it's heads, and you get nothing if it's tails. What do you think the expected value is for that example? So let's go through. If I flip many coins, then it's very likely that the average of all of the coin tosses will be close to what? $50 profit or 50 cents. Okay, so the expected value of the coin toss would be 50 cents. Does that mean that you are going to get 50% heads? Does that mean your average is going to be 50 cents? Definitely not. For example, if I tossed 1,000,001 times, it's not possible to be 50% because you can't have half of 1,000,001 because that would be a fraction. So that's where the close to comes in. So it doesn't mean it's going to hit that expected value. It means that it's likely to be close to the expected value. Okay, if I flipped a coin, let's say 100 times, is it possible that they all come up heads? And you get 10,000, you get $100? Yeah, it's possible, but it is extremely unlikely. Okay, so it's extremely, extremely unlikely to flip a coin 100 times and have them all come up heads. Okay, and in fact, putting your finger through a wall is about the same likelihood, but I'm not going to get into quantum physics with you. Just let you know that. So it likely is really a true word. If you do it many times, you're going to be close to that number. And many means it does not say that if you flip a coin, then you're going to get $50, 50 cents. That'll never happen. One coin is not going to give you 50 cents. It's many coin tosses that will likely to give you an average close to 50 cents. Any questions on the expected value idea? Okay, just a couple notes. One is that a lot of people will use EV for expected value. Okay, by the way, nothing to do with electric vehicles. Just a note. EV, in fact, the letters EV came before even people even understood what an electric vehicle was. Okay, this is like many hundreds of year old stuff. So EV is expected value, not, don't think about cars. The other thing is mu. Why do you think we sometimes use the letter mu for expected value?
Well, isn't that also the average?
Exactly. And what do you see? And what do you see in what the expected value is? Hint, look at the words in red.
Average of the trials.
It's average. Okay. So that's the reason why we use mu. So it's a theoretical average. Okay. Then there's the summation of x times p of x. So if you love math, then you should definitely play around with this. If you don't, then you're not responsible for it. Sound good? So that's up to you, but I guess I'm supposed to show you this, but you're not going to actually use the formula. What's more important is you understand what the expected value is all about. Okay, my job is to deal with this stuff when I wrote the program, the calculator program, but you don't have to worry about that. Any questions on the idea of the expected value? Okay, so now let's go back to the question, which is, let's from what we just did with the car salesperson example, and I think I'm going to copy and paste that table. Because we'll need it. And it says, find the expected value and standard deviation for the car salesperson example and interpret the expected value. Is this a lucrative job? How should the salesperson react to the standard deviation? Okay, do you understand what the question's asking? Any questions on the question? So how do you think we're going to go about doing it? Just a guess. Any guess? I don't see you all jumping in. Okay, what you're gonna do is you're gonna go to the calculator. I'm gonna write these down so I don't lose them. Thought I had them, but 190, 290, negative 10, 0.12, 0.08, and 0.8. So let's go to the calculator. Let's go calculator. I try to make it as easy as possible, but again, if you ever have a suggestion to make it easier to read or understand, let me know and I can tweak it. And just to let you know, one of the good things. Okay, so I see you did the calculation, which is great, kind of. Good luck with the standard deviation. All right, that's much harder. So it's not good enough to just get the expected value. We want standard deviation too. So in the calculator, which number do you think we're going to use? I tried to make it obvious. Yeah, number 6. Okay, and what it says is put in the table. This one does by columns instead of rows. So X is 190. And then the probability of X was 0.12. And then the next X was 290. And its probability was 0.08. And then the next X was negative 10. That came from the table. And its probability was 0.8. Any questions so far? Does this look hard? Again, I tried to make it as easy as possible. Okay. And then calculate.
Can you scroll back up?
Okay, let me know when I can scroll back down because I had to put in more so that in case you have a bunch of X's, that would work in the calculator.
Okay, so what is P of X?
Probability of that X occurring. So the probability of a $190 profit was 0.12. Do you remember that? That was in our table. Maybe it'll help to see the table again.
That's fine.
See the X and P of X? So you have the X with all these values and the P of X with these values. So it's the same table. This just uses columns and I use rows. Okay, so the expected value is 38. And the standard deviation is about 98, all around to the nearest dollar. All right, so let's write this down. EV was 38. What do you think? Good job, lucrative, not lucrative? So by the way, I have a question for you. I have no idea what the answer is, but maybe one of you knows. How long do you think it takes to work with someone and test drive a car and possibly, you know, sell that car? Whatever you say.
5 hours.
You get 5 hours to test drive that car?
Oh, I thought you were saying like to buy it and everything, test drive it, buy it, do all the paperwork and everything.
Just a salesperson, not the office people.
Oh, maybe like 20, 30 minutes.
Okay, 20, 30 minutes. Okay. Remember that, yeah, it's not just one person working in the whole building. Okay, you're making this commission. Other people might make other money. Does that make sense? Okay, so let's say it takes 30 minutes. I'll go on the long side. Then what do you think? Good job or not? As an hourly wage.
Good.
Yeah, this is a, what, $76 an hour job. So if it took 30 minutes per customer, remember, a lot of them are going to be real quick because you're going to test drive the car. They're going to say, I hate this car. They're going to leave. You're going to try and schmooze and get them to buy, and they're just going to say no. Okay. So some are going to take longer than others. But let's say it took an average of 30 minutes per customer. Then the expected hourly wage is, again, 38 times 2 is 76. $76 per hour. Okay. Would you take that job if you're looking for money? What do you think? Is that good wages, or maybe your job makes a lot more?
Hell yeah, I would.
Not enough. Just kidding.
I do want to let you know I made up these numbers. So don't like get the job and then get mad at me because you're not making as much money as I'm saying. I did make the numbers up, but I want to let you know these are the kind of things that you do in business. Is what you do is you research, and you usually collect data to see what it seems to be, and then based on that you find the expected value, and that tells you whether you have a successful, business or not. And by the way, if the expected value is negative, don't even think about it. Do you agree? Okay. I mean, that'd be stupid because then would you expect to be losing money? That would be dumb. Okay. On the other hand, the standard deviation, all right, SD for standard deviation, was 98. What does that tell you? If the standard deviation is 98, what does that tell you?
Spread of the data is like very wide.
Yeah. What does that tell you in terms of if you're the person getting this job, you're just starting out? What plans are you going to make?
Have another job that's a more stable source of income.
Okay, you can have another job, and that will work. But what I recommend, probably even better, is just have money in the bank. Because there'll be some weeks or some days that you do terrible. You actually may be losing money that day. And there'll be some really good days. Does that make sense? And that's what it means to have high standard deviation. It means that your values fluctuate up and down a lot. Does that make sense? So it's not that it won't be good at the beginning. It's that it might not be good at the beginning. Do you see? You might get that $290 in the first person. Be awesome at the beginning. Okay. But you also might not make any money at the beginning. So the idea is, the recommendation is to have a significant amount of money in the bank at all times to deal with the bad days that will inevitably come. Any questions on that? I do want to let you know the number one reason why businesses fail in their first year is they don't do their research, they don't do their data, and they don't have the financial backing to be able to handle that first year that might be bad. Okay, it's very typical. So you do your best to get good data so that you can come up with the expected value, look at the standard deviation, and then make sure that you have funding for the bad times. Okay, so that's really important for business. Again, I'm sure you're not all going to go into business, but some of you are. And that's a big piece of advice that comes from statistics. Any questions on this example? Okay, so here's another example. Yeah, if he had zero money, he could pay all workers for a year. Okay, and did Bill Gates do well, by the way? What do you think? yeah, right. Horrible, only worth 90 billion. Yeah, so Bill Gates did well, but that was one of the reasons, not the only reason, but that was part of the reason why he did well, is you have to be ready. Okay, and that's just true for not just work, but actually life too, is that you should always have enough money in the bank to handle the bad times. Okay, so here's another question. You have been offered a life and dismemberment insurance policy. Costs $1,000 per year. The policy pays the heirs $100,000 in the event of death and $50,000 in the event of dismemberment. The actuaries have determined that you have a 0.3% chance of dying this year and a 0.5% chance of dismemberment this year. Find the expected value and standard deviation. Okay. And by the way, to do that, the first thing you have to do is a probability distribution table. Interpret the expected value, then explain why the standard deviation might indicate that it still might be a good idea to purchase insurance. So I think I want to give you 5 minutes to go work on this. Because again, to me, it's so important that you do instead of watch. So what I'm going to do is I'm going to put you to work. And what you're always, when we're doing this kind of stuff, is you're welcome to ask questions if you had them as you're working. And I can help you out. Probably can help too. And so whatever it is that you're not sure about, let's see if you can do it. It's similar to the one we just did. It's not the same. But let's see if you can do it. And it shouldn't take more than 5 minutes. And just a note, in case you want a quick little link. I just posted the link to the calculator in the chat box to make it easier and faster. So give it a shot. Just the next 5 minutes. And hopefully you can all get the expected value and standard deviation. And then interpret. And make sure you include the important keywords that I put in red. And I'll be watching the chat box in case you have any questions. What's dismemberment? So example of dismemberment is if you have an accident and your hand gets chopped off. Or maybe a knife goes through your eye and you go blind. So all the really bad things that could happen to you, but you don't die. Does that make sense? And there's a lot of policies. So basically you become disabled because of some disaster, but not dead. And that's standard in a lot of insurance policies. Okay, give you one more minute, and then hopefully you've got this down. Not sure if mine's right. Standard deviation is really big. Standard deviation is really big, by the way. So yeah, if you got a big standard deviation, I mean, it shouldn't be a trillion, but it's not going to be small. Yeah, standard deviation is big is a good thing. Okay, so let's take a look. First thing, any questions on the probability distribution table? So I figured while you were working, I'd type that out. So notice it's kind of a profit idea. You pay 1,000, you get 100,000, or your heirs do, and that's 9. Whoops, one more 9. Let's see. Yeah. So you get 100,000, so it's 99,000. That was right.
Yeah, you're right.
That was right. Okay, and similarly, 50,000 minus 1,000 is 49,000. And then if your policy doesn't pay off, You paid 1,000, you get nothing. So that means your profit was negative 1,000.
How do you get P of X for the negative 1,000?
Okay,
Oh,
so
oh wait, you added those two and then you subtracted it from the 1,000, didn't you?
exactly.
Okay, thank you.
One of the good things about this chapter is that there's really only two kinds of problems. This is one of them, and we'll do the other one in the last bit of the class. The last ones I think is quicker, less things to understand. So any question? Now, did you put it into the calculator? And what'd you get for the expected value? I can't do this in my head, but what'd you get?
-450.
Negative 450. I heard two people got the same thing. That's a good sign. And the standard deviation was
495.
495.
6,495.
That sounds better. 6,495.
0.96.
0.96. Let's call it 6,496. No one cares. No one cares about less than $1 on a life insurance policy. I hope you agree with that. Okay. Any questions on getting the expected value and standard deviation?
Can you
All
put
right,
it into
so-
the calculator for us?
What's that?
Can you put it in the calculator for us? For some reason, I kept getting where'd it go? For some reason, it wasn't coming up, even though I put all the information into the.
Did you read this sentence right here?
Hold on, wait. Where'd you?
Did you read the last sentence? Because that's is that where you made a mistake? Did you put commas in?
Yeah.
Yep. You put commas in, the calculator can't handle it.
Okay, thank you.
Yeah, and in fact, I didn't used to have that sentence, and then a lot of people are having trouble, so I put that sentence in, and hopefully that'll help. Okay, so now let's interpret it so that we could say, so here's the thing. First thing, you're not going to get many life insurance policies, and you don't get many lives. Okay, that'll never happen. Well, maybe if you're in one of those interesting religions, you think you might get many lives, but I'm not going there. But we could look at it in terms of the life insurance company, like if they're going to advertise, right? If many people purchase this life insurance plan, then it is likely that their average profit will be close to. And that was negative. So instead, you probably don't want to use profit, you probably want to use loss. Because negatives, you don't usually say negative profit, you say you have a loss. Will be close to $450. Okay, is this something you want to purchase? What do you think? Is it a good purchase?
I would say so.
So it depends. Okay. If your hope is to, on average win money, it's a bad idea. But that's not what life insurance is about. So it really depends on your financial situation, on your life situation. So for example, if you just gave birth to a baby, you might want life insurance because you have this big standard deviation, which means that things could go bad. By the way, life insurance is the one thing you don't want to end up making money on. Do you agree? Because that means you died, or maybe you had your hand chopped off or something. So it sounds like you want the money, but you actually don't want the money. But you want to make sure that your little baby is not going to be like messed up because now you're financially ruined. The baby has nothing. So this is one of those with the big standard deviation. Things could go up or down. And what you want to do is you want to say, hey, if you have a dependent, then that standard deviation tells you that it might be worth it. Okay. Even though your average is a loss, but with this big standard deviation, it's sometimes good to hedge your bets. On the other hand, if you have no dependents, and there's nothing really, no one gets hurt if you die, this kind of would be a bad idea to buy life insurance. And that's an example there. Because what, your government is going to get your money because you didn't actually have a will because there's no one to give it to? Unless you want to give money to the government. So any questions on this idea? Okay. So I had a big policy when my daughter was little. My daughter is an adult now. I'm not upgrading that policy. I don't need to. Okay, because there's no reason. I don't have a little kid that's going to be in trouble. Okay, and I own my house and stuff like that. We'll talk about the stock market later, not today. Any questions on this example? Okay, let's take a 5-minute break. It's 5:06. I'll come back at 5:11. I am not going to pause the recording because that was a disaster last time. But I think I'll stop the share and I'll come back in 5.
Sorry, Larry. You're gonna let the share continue, right?
Yeah, I got to let the share continue because last time I didn't.
Right,
And then I turned it back on and it didn't record the last part. I'm not exactly sure what happened, but I don't want to take that risk again.
Okay.
This is the 5 minutes with my cat. You get your cat too.
Yes, I'll have
Hi. She says hi.
Split my fingy like a grape today.
Ouch. Well, I'm a math guy. I can't help you with the medical stuff. Sorry.
We're talking about insurance, though.
Yeah, it's almost well, hopefully it wasn't dismembered. Hopefully you don't lose your finger.
Probably
But,
gonna lose the finger now. I
yeah,
crushed it between a bed and the cab of a truck today.
Oh, sounds bad.
Yeah.
Put some ice
And
on it.
Yeah, it wasn't a cut. It was literally crushed to the point where my finger like split open. It was pretty good.
Oh. Yeah. If it's, you might have broken it. You might want to think about a doctor.
No, I went to urgent care to make sure
Oh,
I
you
didn't
did?
shatter it.
Yeah.
He told me if it was any higher, I would have just shattered my knuckle though.
That would have been bad. Yeah.
Yeah. And I felt it coming too. I went to pull my hand out, but too late.
Oh, no fun at all.
Yeah.
And are you left-handed or right-handed?
Right-handed, so writing on my notes has been
Oh no.
yeah.
Okay, it's 5:11, so let's get back. And I'm going to share my desktop again, and we can talk about the next bit of information. Okay, so this chapter really has two main parts. So we just finished the probability distribution tables, the expected value, and the standard deviation. And now it's time to talk about the next part, which I think is a little bit easier, actually a lot easier. So that's why we're not spending quite as much time on the second part. And that is the binomial distribution. And when I say easy, it just means that there's not that much to say. Easy does not mean not important. So this is still important, but it's just not as many details. Okay, definitely not as many words to deal with. So here's a big definition, and that is a binomial distribution comes from multiple independent trials of a yes-no question and measures the number of yes answers. So that would be something like you do a survey and you ask, 300 people, and you say, hey, were you out of work in the last year because of COVID? Okay, and that's either you were or you weren't. Okay, and so that's a yes no question, and then you count how many people say yes, and that's a number. Notice it's discrete because the number of people who say yes can be listed. If you ask 300 people, it's somewhere between 0 and 300, but it can't be 200 and a half or something. So it's a list, and the distribution of the possible answers, the possible number of yes answers, is called the binomial distribution. Any questions on this idea? Okay, and they come up a lot. Okay, it's very often that you do a survey and you want to see what proportion of the people say yes to whatever the survey is. I want to mention that in most textbooks, they use some different words that I hate, so I purposely am not writing them down. And they call the yes answer success and the no answer is failure. Do you know why I don't like that?
Because it could mean the opposite technically for something.
Yeah, it could be like, for example, let's suppose the survey question is, you work at a hospital and you're looking at heart surgery, and the question is, did the person die? So some will be a yes and some will be a no. You can't kind of die. You die or you don't die. So I don't like calling that a success if they died. So I'm not sure why the statisticians call yeses success, but just let you know, if you read the book, you'll see success there for the yes answers and failure for the no answers. But the word success does not necessarily mean a good thing, and failure does not mean a bad thing in this particular situation. So I'm going to stick with yes, no. Sound good? Just it's hard for me to call it success and failure when there's some situations where you shouldn't even say that. Okay, so very easy. So here's an example. And I have a bunch of questions. We'll see how many we get to, but we'll get to some. Okay, so I looked this up today, actually. That's the thing about I really like about this class, is it's really easy to read the news and find something that's happening today and put it right on the examples, because stats is used everywhere. So this is, and hopefully, actually during break, I saw the new news. There's actually bigger, there's the number one headline, which is that there'll be a survey in that too. You guys know what the number one headline was? Not about COVID?
Derek Chauvin.
Yep, guilty. Guilty. So we're not going to go there because I didn't have time to set this up during break. But that was number one, is guilty. Okay, I'm not going to get political about that, but that was the news. But the other big news that's happened, very recently, is as of today, according to the LA Times, is where I read it, 42% of all Californians have received at least one dose of a COVID-19 vaccine. Okay, so that's a good thing. And I'm not sure if you realize California is #1 in the country for people getting vaccinated. Okay, and we actually have the biggest drop in number of COVID cases in all of America. So if you're planning on traveling, be careful because California is a good place. Or if you're not in California, be careful. Okay, if 15 randomly selected Californians are surveyed, what is the probability of that? And the first question is between 5 and 10 of them have received at least 1 dose. Any questions on the question? Any questions? Okay, is this binomial?
Yes.
Yes, because what's the survey question?
Have you been vaccinated?
Yeah, or have you gotten at least 1 dose of the vaccine?
Yeah.
Yeah, because having been vaccinated, that's not necessarily yes, no, because that's kind of, but 1 dose, that's yes or no. You can't kind of get a dose of the vaccine. That doesn't happen. You either got it or you didn't get it. Okay, so for example, if you ask me, I'm a yes. Okay, and hopefully you guys will be yeses too, or already yeses. Okay, so that's the first thing, is to just note that this is a binomial problem. And that's often the hardest part about the whole thing is identifying that it's binomial, especially on the final exam where we've had a whole lot of different things in the class. And you got to remember this from way back when, okay, because it'll be, over a month from now. Okay, in fact, 2 months from now. So we want the probability that we're between 5, all right, less than or equal to x less than or equal to 10. And that's what we're interested in. Any questions on that? All right, so now, hopefully you're used to this. How do you think we're going to figure this out?
Figure out the expected value.
No, it's much easier than that. What do we usually do at this point? Guys, remember? Go to the calculator. That's it. I told you this is an easy one. This is not like the other examples. These are easy. But what you have to do is you have to, one, identify its binomial, and the other is be able to write down x is between 5 and 10. Part A is easier. Some of the other ones are a little harder. Not too bad, though. So let's go to the calculator. And as I mentioned, I tried to make it easy. So I'm going to drop back to the calculator menu. And as I mentioned, I did everything in order. So what do you think? What number do you think we're going to?
7.
Number 7. Okay. So then we got to plug in, what is the low?
0.
Okay. Remember, the question is find the probability that between 5 and 10 of those 15 people were vaccinated with at least 1 dose. Yeah, the low is 5. Because if there's 5 people vaccinated, that's in the between 5 and 10. If there's 4, that's not. If there's 6, that's higher. Do you see? What's the high?
10.
10. Okay, not 15, because if there are 15, we're not between 5 and 10. How about trials? How many trials were there?
15.
Now 15. So number of trials are 15. There were 15 people that were surveyed. And what's P? See if you remember.
0.42.
0.42. Okay, which is pretty amazing. I mean, California, we're on it. Okay, we're getting higher and higher and higher. Okay, and then any guess what I have to do now?
Calculate.
Hit calculate. Okay, I really tried to make this easy. And you get 0.8118. Any questions at all on this example? Okay, what's the probability that at least 7 of them have received 1 dose? Okay, so that's the probability. What's at least 7 in symbols?
Greater than or equal to?
Yeah, so X greater than or equal to 7. Any questions on that so far? So let's go to the calculator. All right, what's my low?
7.
7. What's the high?
15.
Yeah, we do need to have a high. The high is 15. At least 7. You can't have 16 because we only are asking 15 people. So the highest number of people that would be at least 7 is 15. Does that make total sense?
Yeah.
And then the number of trials is still 15 and the probability is still 0.42. And hey, calculate. 0.453. Any questions on that? Okay, now let's go part C. Is what's the probability that less than 9 of them have received at least 1 dose? So what's that the probability of?
X less than 9.
X less than 9. Okay, this one sometimes is a little harder for people. What's the low for X less than 9? 0. Okay, 0 is definitely less than 9 and you can't be less than 0. What's the high for X less than 9?
8.
8. So that's the thing to note. A lot of people make that mistake. 9 is not less than 9. So 8 is the biggest number that is less than 9 for whole numbers. And then trials and P are the same. Any questions on that? And it calculate 8.8746. Any questions on this? Okay, does this look pretty easy? What do you think? Or does this look hard? Yeah, if you practice, this is easy. So I would say compared to chapter 3 questions, on a scale of 1 to 10, this is like a 2. And chapter 3 questions are more like a 9. So we're in the easy chapter. Do you like easy? Okay. Again, the main thing is 2.5 months ago, you still got to remember it. That's the hardest part, is keeping your memory going 2.5 months later. So what you want to do is 2.5 months from now or 2 months from now, before the final exam, just practice a little so you can, get the easy ones right. Okay, exactly 6. So it's a probability that X is equal to 6. This is a little weird looking. It's not hard, but it's a little weird looking. What's the low to find the probability of exactly 6? Yeah, the low is 6. And the high is also 6. Because exactly 6, you can't be less than 6. You can't be greater than 6. You have to be 6. So low and high are both 6. Any questions on this example? And you calculate 0.2041. That's that one. There we go. Any questions at all on kind of this example for the binomial distribution? Okay, we have some more time, so let me give you another problem. And I'm going to do this, and this will help you out also for the project. Any excuse to help you on the project is a good excuse. And because I haven't popped this in, and this is something you have to use for your project, I haven't popped this in today. Let me pop in the sorry, I have to move your here. Sorry, with Zoom, things get in the way when you're popping something in. And I'm gonna pop in we'll just use this data. I don't even remember what it was from, but let's suppose that you had a bunch of people. You did this big survey question, that's very quantitative. And we're gonna look at a box plot. So do y'all see the box plot? Okay, so now here's the question. If I asked 20 people at random, what's the probability that more than 12 of them are going to answer with a number that is bigger than less than 381.5? So I think I need to do it this way. I wonder if it'll let me. I never tried this. Yep, copy. Look at that. Okay, so if I ask 20 randomly selected people, what is the probability that more than 12 of them will answer the survey question with an answer lower than 381.5? So I wanted to put this in so I could review at the same time. This kind of, and I do this a lot on tests, so be ready, is sometimes it's good to bring in other chapters at the same time. How do we come up with that? So what do we have to do here? Okay, so the first thing, maybe we can look at it. Maybe we can get some of the stuff. So we want the probability that what? X is what? So what do I pop in? I don't see y'all jumping in. So what's it say in the question? So read the question. What inequality do we have?
X greater than 12.
Greater than 12. Okay, so let me go in here. If we want X to be greater than 12, what's the low?
13.
13. Okay, and then it might help to look at this again. What's the high going to be?
20.
20. How many trials?
20.
20. Okay, now comes an interesting part. How about P? Because we need P. What is P? I'll let you look.
Is it 70.75?
Yeah, and how'd you get 0.75?
Well, because isn't the red part that interquartile range?
Exactly. The red part is the interquartile range. So in particular, the top of the box, we call it the box, is the third quartile. And the third quartile is the 75th percentile. Any questions on that? Which means there's a 75% chance of being below that number. That's what a percentile means. Any questions on that idea? So that means that I can go into my calculator and I can, for my probability, I can do 0.75. Okay, and my guess is that was the hardest part of the whole thing, was to be able to put together something that happened in chapter 2 with something now we're in chapter 4 and bring them together. And then if I calculate, I get about a 90% chance. Any questions on this idea? Any questions? Okay, let me do another mixed problem. Drop our quiz again. Let's say we randomly select 16 patients, okay, who just had surgery. What is the probability that at most 8 of them had local anesthesia? Any questions on the question? So let me type it out. Suppose we randomly selected 16 patients who recently had surgery. What is the probability that at most 8 of them had local anesthesia? I got it right. No, I didn't. I never spelled that word right. There we go. Any questions on the question? All right, how do we answer this question? Well, let's write down. It's always good to write in symbols. What's at most 8? X, what's the inequality?
Less than or equal to 8?
Yeah, less than or equal to 8. Okay, these aren't trick questions, but again, the more practice, the better. Okay, I think I'll do the following, since we got a little time. Let's see if you can answer this question. Let me pop in the quiz again. So what is the probability that at most 8 had local anesthesia? And in fact, maybe I'll even do the following just to make it easier for you to answer. I can literally put it in. Let's see if you can answer this question. Again, you will need a calculator. And there, by the way, there is a way to do it with math, but we're not doing that. It's too messy. It's really messy. So I'll give you a few minutes and let's see. It shouldn't take more than a minute or two. And when you get it, maybe you can pop it in the chat box. And again, this is a nice combo of chapter 3 and chapter 4.
What goes in for P in this one?
That's a really good question. That's probably the hardest part of this one. So remember, P is the probability that a single individual will say yes. And the survey question is, did you have local anesthesia? So given, this is why I'm showing you this table at this moment. Given this table, how do we find the probability that someone will say, yes, I had local anesthesia? Does that help or not, or you need more?
No, it doesn't. I don't know.
Okay, so we need to find out the probability of local anesthesia. So here's the locals, right? Remember, a probability is a fraction. What's the numerator for the fraction? How many people had local anesthesia? You're not sure? Yeah, how many total people? Here's a hint. Yeah, good. So T for total. So 96 total people had local anesthesia. Out of how many? So 96 is the numerator. What's the denominator?
259.
259. That's how you find P. Does that make sense? So 96 out of 259 will be the P. Okay, and what you'll need to do is, actually you could do it here. Click it, scientific calculator. You go 96 over 259, and that's 0.370656, whatever. So we can call that our P. So that's how you get P. Any questions on getting P? That's the chapter 3 part of this problem. Now let's see if you can finish it off. So randomly selected 16 patients. What's the probability that we're less than or equal to 8? Hopefully the rest is pretty easy. Yeah, a few of you are getting it, I think. Okay, so less than or equal to 8, 16 patients. Then I go over and the low is 0. It's the lowest number that's less than or equal to 8. That's positive. 8 is the high. There were 16 patients. And hit calculate. 0.9064. Okay, you might get something slightly different if you carried fewer decimal places for your P. I just kind of copied and pasted a bunch. Any questions on this idea? So I do want to mention that it's good practice to combine stuff that you did in the different chapters. Because that one thing is it helps you review the older stuff, right? Now you got to review the box plot. Okay, and here you got to review chapter 3 a bit. So again, combining is a good thing. So we have a little time, and here's what my plan was for the little time left. I'm actually gonna stop my screen share. And I think I'm gonna stop my recording too, because that way maybe you'll feel more comfortable, I'm not sure. But this is the end of the recording.